Hello everyone, my name is Siti Nazihah. We are from Group A for Section 21 Engineering Statistics. And today we will be presenting about pil Lajak Curih, which is we call a tablet. For introduction, Lajak Laku is a manufacturer that produce health supplement diet tablet called Lajak Curih. The company produced at least 15 types of Lajak Curih tablets with different health properties. In April 2022, there are 200 sample observations taken at random from 3 production shifts run daily, namely morning, evening, and night. Objective for this project is to ensure tablets uniformity at every batch produced so that further corrective measures can be taken at the shop floor. So I am going to present regarding to part A, which is part A is taking about the summary of the sample data of pil Lajak Curih A tablet produced in April 2022 in numerical, tabular and graphical form. So we look at for the first one, which is numerical form, for summation of data, which is sum of weight, sum of relative density, and lastly sum of tensile strength. Next, we proceed to the mean data for each shift, which is morning, evening, and night. And last one is numerical data of weight, relative density, and tensile strength. Then we proceed to the tabular form. Here we have weight, relative density, and tensile strength that we got from the table. Last one is a graphical form. We have average of weight, average of relative density, and average of tensile strength. And this is a graphical form for frequency of weight, frequency of relative density, and also frequency of tensile strength. That's all from me. Thank you.
Hello everyone, I'm Alia Ashika and I will present on part B. For this question, first we need to collect all the data and conduct a frequency table. This is the frequency table where this is the range of the weight, which is 10. Next, this one is the count where we present the frequency and the total count is 200. On the next step, we need to do is the hypothesis statement that we know that H0 is state that the data follow the normal distribution with mean of 350 and the H1 is state that the data do not follow the normal distribution with mean of 350. In the test statistic part, this test statistic table shows that I, X, OI, P, and EI. OI means that the observed frequency of the image is which is expected frequency, and P is the probability. In this case, we calculate the probability by using the normal distributive formula. After that, we need to calculate the EI, which is the expected value, by using the probability times the gram value, which is 200. But in this case, we need EI more than 5, so we need to brush up until reach 5. So we combine these two set row so that the EI is equal to 15.28 and we get the total is 200, which is as the observed frequency, and the probability we get is the total up is 1 on the next table, which is we collect all the data from the previous table. We need to calculate the chi-square test, which is the x square equal to OI minus EI square and divided by EI, so we get our answer. The total of x square is equal to 2.6395 and we need to calculate the x square alpha V2. We know that alpha is equal to 0.05 and the V is equal to 6 minus 1, which is 4, and we get the n x square alpha V equal to 9.5877. Since the x square test is smaller than the x square alpha V, so in this case we can conclude that the H0 is felt to be rejected and the data is following the normal distribution based on the requirement with 350 mg mean and the standard deviation of 4.
Okay, my part is from part C of the assignment. This is to find the analysis of whether there is any significant difference between tabular weight milligram from different shifts using ANOVA in Microsoft Excel. Okay, in the next slide we can see that the weight production in 3 different shifts: morning, evening, and night. In the morning we have a total of 67 weight. For morning, evening we have 77, and night we have 56. Okay. Okay, the second step is we need to do the hypothesis statement. H naught equal to ui equal to u2 equal to u3, which is equal and the same. So there is no significant difference exists between tabular weight from the differential. While the second one is h1 equal to ui is not the same as uj. For at least one ij I is not equal to j. So there is significant difference exists between tabular weight from the differential. Okay, the second step. Okay, the third step is we need to do the test statistic. The first table are the summary of one week ANOVA from Excel, and the second table is ANOVA, and we can get the degree freedom, mean square, F grade, p value. Like, okay, the third step. So in conclusion, the p value, the F is more bigger than F calculated. The F is 3.041753 is bigger than 0.5398. There is no significant difference exists. In the second one, we can use the A equal to 0.05, p value is 0.947461, which is the p value are bigger than A. So from the output, p value is 0.947461, and suppose we choose this level significant A equal to 0.05, we will noticeably the p value is bigger than 0.05. Therefore, we fail to reject H naught and conclude there is no significant difference exists in the mean at 0.05 level of significance.
Hello everyone, my name is Wilson. Today I would like to discuss about the Part D analysis of the relationship between the relative density and the tensile strength of the turbulence harness regardless of the productive shift. The sample linear regression is used. The variable of the sample linear regression. The independent variable is the relative density, the dependent variable is the tensile strength. From the Microsoft Word Excel, we get the regardless static table. The correlation coefficient R equal to 0.8573. If R equal to 1, means the impedance is strong positive linear between their two variables. From the table, we also get the alpha equal to 0.1729. The beta is equal 0.07920. So that we form the simple linear regardless equation. Y equal to alpha plus beta x. Y equal to 0.1729 plus 0.07920 x. From the data, we get the linear graph. This is the positive linear relationship. Then we determination of the predicted tensile strength at the given relative density. We substitute the value into the equation just now we get from the linear regression. We substitute the value 68, we get the 5.5585. We substitute the value 74.3, we get 6.0575. Then we substitute the value 80.1, we get 6.5168. Then we test for the derivative of the regression. The hypothesis statement is H naught equal to beta equal to 1. H1 beta not equal to 0. The H naught beta equal to 0 means that the linearity does not exist. If the H1 beta not equal to 0 means that the linearity exists. So that we do the analysis of F-test hypothesis at 95% of the confidence interval. From the ANOVA table, we get the F-test value 548.8 85.954.004. The significant value is for f is equal to 5.38506 power of negative 59. Seeing the value f equal bigger than the f test, so that the Hess knot is rejected. So we can conclude that there is a stronger linearity relationship between the pi-legged cooling A table relative to the relative density and the tensile strength exceed at 0.05. So we conclude all the project. The situation of the polarity in the Applus 2022, there is the significant evidence that table follow the normal distribution with the mean of 350 mg and a standard deviation of 40 mg. No significant difference between the pi-legged cooler A table with from the different shifts. Finally, we also accept of the linearity in the Dirichlet's mode between the relative density and the tensile strength. That's all. Thank you.